Okay, now we're finally ready to really tie this all together using our periodic table. We are discussing electron configurations and orbital diagrams. And here is a picture of the periodic table, very much like what you should have had from your inquiry. I'm just going to be putting in my period numbers, 1, 2, 3, 4, 5, 6. Now this is 1, 2, 3, 4, 5, 6, 7. Now the F block, for our purposes, we're going to be hopping out of the F block right here and going into this. So this is period 6, this is period 7, and that's where we're going to take a little detour on our journey. So I like to talk about this as a walk through the neighborhood. Now the first example in your notes, we're on page 15 of your notes, and the first example that we'll be working through is zinc. Now let's find it on the periodic table. Zinc is right here on your periodic table. Now, one last thing before we're ready. Remember, in the S block, our energy level is equal to our period number. For our P block, our energy level, N, is also equal to our period number. So period 2, N is 2. Period 3, N is 3, and so forth. For the D block, N was equal to the period number minus 1. And then for the F block, N was equal to the period number minus 2. You got to learn that because you're not going to have all this little writing right here there for you. Okay, so let's head on our journey to zinc. Right here is zinc. So you find it on the periodic table. We always start our journey at home, and we always read left to right. So we're going to start here, and we're going to make it all the way through here and here. And we're not there yet. It's like being on a trip and asking mom and dad, are we there yet? Are we there yet? Are we there yet? We're not. So we have 1s2. Then we're going to wrap around. You always start left to right. We're going to go all the way through the 2s, and we're not there yet. So we went all the way through the 2s and filled it. Now we're going to walk across the ravine. And you notice we're in the 2p block, period 2, p block. So 2p. Now, we have to completely fill it. We're going all the way through and we're still not to zinc. I'm going with a better color here. So it's 2p6. Okay. Now, if we stopped our journey, we're right here, but we've got to get all the way to zinc. So we start left to right again. We're going to go all the way through the 3s, so that'd be 3s2, cross the ravine, and we're in 3p6. We're going all the way through it. Now start back again, left to right. We're 4s2. Now be careful. When we go from the S to the D, it's almost like going down a little hill. And instead of 4D, it's 3D. And we're going to fill it to get 3D10 for zinc. Now, if you wanted to do an orbital, you could do an orbital diagram left to right. You could do 1s2, then 2s2. I'm not going to do many of these because these take too long. 2p, 1, 2, 3, 4, 5, 6, then 3s. 1, 2. Notice I'm going energy left to right this time instead of up and down to save space. Then we'd have our 3p, 1, 2, 3, 4, 5, 6. Then our 4s, 1, 2, and then our d's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, a couple of things to notice about this that we want you to be able to identify. The first is, what are our outermost electrons? So our outermost electrons are our 4s, because you go to the highest n value for distance. our highest energy. So let me give you these. I want you to just write this on this. It's not quite in your notes, but I think it's going to be very helpful. Our highest energy electrons are the last we were filling. And that would be our 3D. So these are our highest in energy. Our 4s are our outermost. Now remember, those are also called, our outer S and P are also called our valence electrons. Now, to become an ion, if it's in the P block or the S block, in the P block or the S block, the goal for those two is to reach a noble gas configuration. Okay? Now, nonmetals reach a noble gas by gaining, so these will gain electrons. The metals reach a noble gas by losing electrons. Now, what we have is zinc. It's a transition metal. It's not going to reach a noble gas, but what it does is it loses its outer S and P first. In this case, it's going to lose its outer S. So if zinc lost those outer S electrons like that, then we would have the zinc 2+ ion if it lost those outermost electrons. And that is the most common or the only oxidation or charge, ionic charge for zinc. Okay, so that's one of the things that we want to be taking a look at for zinc. Now, there's another aspect of this that we haven't quite seen yet that I want to show you. There's one simpler thing that we can do to simplify our electron configurations, and that's called the noble gas configuration. I'm going to put it up here because I'm not sure if that's videotaping quite that low. The noble gas. So I want you to write this very neatly where you have it. What you do is you find zinc and you backtrack to the previous noble gas. So the previous noble gas to zinc is right here. And on the periodic table, if you look, that's argon. So you can put a bracket and you put argon. And that's telling the reader that, hey, it's the exact same configuration as argon, except I'm going to add on to it. So you just start your journey. It's like somebody picked you up in a truck, dropped you off at Argon's house right here, and now we're going to pick up our journey from there. Okay, got a little messy, so let's clean up the roads a little bit. Okay, and see where we go. We're on our way to zinc. We were dropped off at Argon's house. That's what the argon means. So we're going to pick it up right here. So it'd be argon 4s2 3d10. Now that would be for zinc. For the zinc ion, we'd take argon, and remember you lose your outer S and P first. So it'd be 3d10, and that would give me my zinc 2+ electron configuration, and that's called the noble gas configuration. And you'll be able to do that sometimes, not all the time, but some of the time. Now we're going to move on. I want to do a couple more examples for you. Whoops, see if I can get rid of some of this for you and without getting rid of my periodic table. So what we want to do, I want to do a harder one. I want to land past the F block. So I want to show you an example that goes past the F block. And so if you'll jump in your notes to, we had bromine and yttrium, and I'd like us to do something like gold. It's in your notes and I'm not finding it, so we're just going to do it. So gold happens to be right here on the periodic table. So let's do a walkthrough for gold. And then I'm going to do one more video just to do a few more. Okay, so we're going to start at the beginning. So we would have 1s2. We're going to cross the ravine. We've filled our 1s. You come back. We're going to go all the way through our 2s block. So that's 2s2. Cross the ravine. We're going to hit 2p6. We're not to gold yet. Come back to the beginning. 3s2. Cross the ravine. 3p6. Back to the beginning. 4s2. Now don't forget, you're kind of going down a little hill here. So we'd have 3d10. We're going all the way through that. And then we go back up a hill. So we go back up to 4p, and we're going all the way through. So count the blocks, 1, 2, 3, 4, 5, 6. 6, and then we're going to come back here, and we have 5s2, downhill to 4d10, all the way through, and then uphill to 5p6, all the way through. Come back to the beginning, and now we've got to be careful. 6s2. Now when we get right here, we're going to take a walk around a cul-de-sac. We're not going to be landing in here at all, but we are going to go through. So we've got to come down here, and we'd go 4f, because remember it's period 6, and n you take away 2. We're going to go all the way through the F block. If you count, it's up to 14. 7 orbitals gives you 14 electrons. And then we're going to swing back to where we were. That's why I called it a cul-de-sac, because we really didn't make it too far on our journey. And then we're at 5D. And then we count in 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to call that 5D9. Okay? Now, if we wanted to do golds abbreviated, and then I'm going to stop because it's a longer video. If we want to do gold's abbreviated configuration, we want to go to the previous noble gas, and that would be this noble gas right here. It's xenon. And all of this, if you did xenon's configuration, you notice it ends in 5p, 1, 2, 3, 4, 5, 6. All of that is xenon, and then we just have to pick up our journey at xenon's house. So it'd be 6s2. We still have to follow our cul-de-sac, 4f14, then 5d9. So for gold, these are our outermost because it's the highest n value. And these, because they were the last we were filling, these would be our highest energy. All right, we want to do just a few more, and I will mark, I think I lost one of my pages here, so I will mark much more carefully what example number that is, so you can write it just where it belongs. And then we are going to move on from there and talk about more ions. So until then, this is signing off.